There you go. Yeah, so this is an exponential function because you have a variable in the exponent. That's what makes it exponential. And Eddie kind of already got my second question here. As we go through, we have a multiplier of a half. That's kind of where it's the repeated multiplication of a half. And so that's the other reason why it's exponential. It's that repeated multiplication. So if we go through and we start plugging some of this stuff in to get the graph. If I take -1 and I plug it in for x, if we do that, I'll kind of write this one out and then we'll go from there. So we would end up having 8 times 1/2 raised to the -1st power. So now if we evaluate that and we actually get an answer for that, remember one of the things I told you over the last 2 days was that anytime you take a fraction to a negative exponent, easiest way to get rid of the negative, you just take the reciprocal. You can just flip the fraction. Okay? So this 1/2 to the -1st power becomes 2/1 to the +1st power, which is just 2. 2 times 8 gives you 16. So there's your first point right there, -1, 16. And when you plug that in. Then if I plug in 0, 1/2 to the 0 power, 1. Gives me 1. 1 times 8 gives you 8. And then everything else from there should get a little bit easier as we work our way through it. As you keep going, we plug in 1. 1/2 to the 1st power is 1/2. 1/2 times 8 gives you 4. And now, once you get, I think I mentioned it to both classes or both cohorts, but once you start seeing the pattern and you really know what the pattern is anyway, you can just kind of work your way through it. You don't have to keep plugging in points and evaluating it. We already said the multiplier was a half. Well, notice it's matching up with what we talked about. 8 is half of 16. 4 is half of 8. So now the next one, just knowing without plugging anything in, it's got to be 2. Then it's got to be 1 because it's half of that. Half of that gives you a half. Half of that gives you 1/4. And half of that gives you 1/8. So you can use the pattern, you can use the multiplier to get those if you want. You don't have to keep evaluating it every single time once you see what that pattern is. Okay, so now if we go through and we just plot some points. Here's our -116, y-intercept at 8. 1, 4, 2, 2. And there's the kind of the basic idea. So now if we go through and we draw this in, oops, where we are, but you get the idea. There is your basic exponential graph, which matches up because of the fact that my multiplier is less than 1. We've got exponential decay, and the graph matches up with that exponential decay, that it's decaying, it's going down very, very, very quickly. Okay? Let me stop there for a second. Does that part make sense? Doing okay on that? Okay, so then let's get into the other portions here. When we talk about domain, what's the domain basically of every exponential function? Yeah, you can take a number and raise it to any power you want. Positive, negative, 0, you can always raise it to any power we want. So, domain is all real numbers. All right, what's the range of this graph? What's my range? Not all real numbers. What is it? Y is greater than 0. There is, and I didn't draw it in yet, but we'll put it in here. There is a horizontal asymptote at y equals 0 right there. Okay? Yep, that's like, remember the analogy I gave over the last 2 days? That it's kind of like that's the goal line, if you remember back to that idea, where it's not going to cross, it's not ever going to quite get there, but it's going to approach that value. So in this case, the range is y is greater than 0. All the y values are above the x-axis. Okay? Y-intercept we already found. Okay, it's right up there. It's 0, 8. We already have that one. And so here's your first question, Michi. When it says change in y values, what's happening to the y values? We're dividing by 2. I want you to think about it, though, as a multiplier rather than dividing. So it's multiplying by a half. That's all I'm asking for. So the change in y values is just times a half. That's all I'm looking for. That's okay, but I'd rather have you think of it as a multiplier. Okay? Because it makes more sense when we move forward with exponential functions. And finally, we already talked about it, growth or decay.
Okay.
This is decay. And there's your answer right there. Okay. The only real difference as I preview where we're headed today is we're going to take this graph and this kind of equation, and now we're going to add in like horizontal shifts and vertical shifts and see how that affects the graph. Otherwise, it's mostly the same stuff. Okay, mostly still working on the same concept, just adding in a few little details. Two ways. If you look at the graph, as you work from left to right, we're decreasing.
Oh.
So that's the decay. Or the other way, when you look at remember your B value,
Yeah.
if it's less than 1, then it's, if your multiplier is less than 1, it's going to keep getting smaller. So that's the decay. Okay, any other questions on this one before we move on?
Is the range always like what
The horizontal asymptote?
Yeah.
Yes. The range will always be one of two things. And this is something we're going to talk about today, actually. The range will always be either y is greater than that asymptote, or there's one time, which we'll talk about today, when it would be, when this whole graph would get reflected, and then it would be y is less than that asymptote, whatever that asymptote is. Okay? But the asymptote definitely is a factor with the range. It's kind of a boundary line, if you will. All the y values are either going to stay above that, or every now and then it'll be below that. And we'll talk about when today. Okay, so there's at least kind of here's where we've been, and then kind of a lead into what we're doing today. So let's take a look. Here is, let me hand out I do have the notes for you today, so you can kind of just add a few things in here. Okay. Okay. So before, what we were taking a look at yesterday, when we introduced this, we kind of introduced what I'm going to call the parent function. Okay. We didn't have any horizontal and vertical shifts. We were kind of looking at just the basics. And so that function that we talked about before was y equals a times b to the x power. That's what we did yesterday, where all we had was an a value and a b value, an initial value and a multiplier. Now, if you notice, we're adding in an h and a k. And if you remember back to kind of the end of first semester, we talked about that. Remember, h is your horizontal shift, tells you how much you're going to take the graph and move it left or right, and k is your vertical shift. Okay. One other thing just to remember about the value of h, remember it's always the opposite of what it looks like in the graph or in the equation. So if this were going to say like x plus 5, then that means h is actually negative 5. It's going to the left 5. Okay? If that says x minus 2, then h is actually 2. It's going to the right 2 spots. Okay? So just keep that in mind. If you notice some ideas here, when you take this vertical shift, notice I put down, that means you're going to have a new asymptote and a new range. Okay? Kind of like what Hannah was just asking about, does the asymptote affect the range? And yes, it does. Well, if I take that entire graph and move it up or down, what you're really moving is that asymptote and therefore the range up or down. So your new asymptote that I'm going to add in here is always going to be at the equation y equals whatever k is. Whatever your vertical shift. If you move everything up 3 spots, then at y equals 3 is when you're going to have where you're going to have a horizontal asymptote. If you move everything down 7 spots, then at y equals negative 7 would be your horizontal asymptote. That also then gives you the idea the range is always then going to be y is greater than whatever that value is. Okay? Whatever that value is, the shift up or down, your y values will always be, or almost always be greater than that. The only time they're not, and I've got some examples where I'll show you all this stuff, but the only time that they are not is when you've got A that's negative. And that's the time where I was going back, and let me go back to our problem that we were looking at here. That's the time where if I had an exponential graph, but my A value was negative, it takes this whole thing and reflects it down. So now the graph is down here rather than up here. That's the only time you would take those Y values and they would be below the asymptote. Okay? So, if we go back, that's what I'm getting at in the lesson when I say the reflection, therefore the new range in that scenario would be that the Y values are less than whatever K is. Okay? It would be below your horizontal asymptote. And then the only other things that I want to kind of be fairly specific about in this case are right down here, and again, Hannah kind of asked about this before, growth versus decay. Remember the B, if your base is greater than 1, if your multiplier is bigger than 1, things generally get bigger. When you're multiplying by 2 or by 3 or by 4, okay, those numbers will go up. If your multiplier is between 0 and 1, then you have decay. So if you're multiplying by a half, you're always taking half of something, or a third, or a fourth, or 2/3. Your numbers will be going down. Okay? So what about right here, by the way? And this actually was one of the problems in your assignment. What about when b equals 1? What happens?
Either 2.
Yeah, and actually nothing was right too. Literally nothing happens. It goes, when you're constantly multiplying by 1, if that's your multiplier, nothing changes. It doesn't increase, it doesn't go down. Multiplying by 1 keeps everything the same. Okay, which is why b is not allowed to equal 1, because then it's not an exponential function. Okay? Let's take a look. Let's go to the next part then.
So the b whatever the 1 under the b equals 1, that's the same thing.
This is just part of the definition that with your multiplier, you're always going to multiply something to get bigger or smaller. And therefore, it cannot be negative. It's just part of the definition. All right. So take a look. Graphing exponential functions. Here's kind of the process that you're going to see me go through when we do these examples, and just a general idea as you work your way through some steps that will hopefully help you kind of follow a process at least. So first one, we're going to identify our initial value A. Normally, if there are no horizontal or vertical shifts, the A value is your y-intercept. Okay? It is your y-intercept if we didn't have an H or a K. That's one of the things that you may or may not have noticed on yesterday's assignment. Okay? That all of the A values happen to be the y-intercept. So that's basically our starting point. We're going to then take that starting point and shift it horizontally and vertically, however much based off of H and K. Once you've then done that, that's basically your first point on the graph, and then it goes right back to the idea of create a t-chart and let's start plugging in some different values of x to try to round out the graph. Okay? And then the rest of it is put the asymptote in there, and then we talk about domain and range, similar to what we were doing previously. Okay? So let's go through and we'll keep coming back to that, but I want you to see it as part of the process. So let's take a look at this problem here. If we are trying to graph this, first thing I want to do is identify what is my value of A, what's my value of B, what are the important values here, and then we'll use them to graph it. Okay? So let's start with this. What's the value of A in this first problem, this first example?
2.
2. Yep. A is 2, which, if there was no H or K, that would be your y-intercept then. If you didn't have any horizontal or vertical shifts here, your y-intercept would be 2. We have some, so it's not going to be, but we'll get to that. How about B? What's the B value?
3.
That's the 3. Yep, that's the base. Okay, the base of our exponential function is 3, which tells me, by the way, exponential growth or decay.
Growth.
This is going to be growth. Our multiplier is 3, so those numbers are going to get bigger very, very quickly. Okay? How about H? What's my horizontal shift based on the equation?
2.
Close.
Oh, 2. That's possible.
Nope.
-2.
-2. There you go. Thank you. Remember, The horizontal shift is the opposite of what it looks like. So since it's x plus 2, it's actually going to the left 2 spots. So h is negative 2. Okay? Oh, yeah. So then the k value, there isn't one. There's nothing added or subtracted at the end. So in this case, there is no vertical shift. We didn't move the graph up or down at all. We just moved it to the left 2. Okay? So now, we've identified the important parts. And so if you go back to my steps here, we did part A. We identified our value of A, our starting point. Now we're going to move it. Okay? So normally, I told you that the A value is your y-intercept. So if normally we would be at positive 2 on the y-axis, excuse me. My h tells me I'm going to take that point and move it 2 to the left. So no, don't draw this because it's not accurate right now. I just want you to see where it normally would be. Normally it would be right there. But because my horizontal shift is negative 2, we're going to take that point and go 2 to the left. And that's going to be our starting point. So there is the first point on the graph that I know. We shift our A value, in this case only 2 to the left. I don't have to go up or down at all. All right, then let's pick some points on either side of that so that we can now start to just kind of get a decent sketch of what's going on. So this x coordinate's at negative 2. Let's pick a couple more on the left to the left of that, and we'll pick a couple to the right of it, and then we'll put it all together. So let's pick, for example, let's go with negative 4 and negative 3 for x values. And that's 2 spots to the left. And then we'll go a couple to the right. We'll go x equaling negative 1. And one of the points I'm always going to pick is 0, because I want the y-intercept. I want to know what the y-intercept is. Sometimes it'll be off the graph, just as a heads up, but I always want to at least know what the y-intercept is. Okay? All right, now we evaluate. Now we're back to kind of like what we were doing the other day. So if you take a look, if I plug negative 4 in, and I'll do the work at least for these first couple so you can see it. I'll try to do it up here. So we've got y equals, this is not easy to write out, 2 times 3. What power would 3 be raised to if I plug negative 4 in? For x. Negative 2. So we end up with 3 being raised to the negative 2nd power if you're plugging negative 4 in for x. You get negative 2 as an exponent. So now we evaluate. Remember order of operations. We take care of the exponents first, parentheses, all that kind of stuff. Just remember back to PEMDAS again, way back when. So if we do this, we get 2 times, what's 3 to the negative 2nd power equal? 1 over, yep, you have the right idea. So 3 to the negative 2nd power is 1 over 3 to the positive 2nd power. Okay? So 1 over 3 squared, which is, yep, so you end up with 2 times 1/9, which is 2/9. There's your answer for that one. At negative 4, you're at 2/9. You've got a y coordinate of 2/9. It's not the nicest thing in the world, and that's one of the things you're going to find today, and that's why you're not going to have a ton of these types of problems. But it's something that you got to kind of work our way through a little bit. Let's say we plug in negative 3. And we'll do that one up here again as well. Y equal to 2 times 3 raised to what power then? Hold that thought. I know what you're doing. You're on the right track. You're doing. What power would I get if I plug in negative 3? Negative 1. And now we evaluate. That equals 2 times 1 over 3 to the first power, which is just 1 over 3. And now we get an answer. 2 times a third is 2/3. All right, and now it actually turns out that it starts to get a little bit easier. We're going to do a little bit of this in our head now at this point. Because now when I plug negative 1 in, what's the exponent going to equal? If I plug negative 1 in, 1. Well, 3 to the first power is 3. And 3 times 2 gives you 6.
What did you do for 2/3? You could do 3 times 2/3. I don't know. Put the next 18.
You're trying to use like the multiplier? Yeah, so, well, hold that thought. Let me do the last one and then I'll talk about it. So the last one, if I plug 0 in, I get an exponent of 2. So 3 squared is 9, and 9 times 2 gives you 18. There's your y-intercept. And if you notice, it's not on the graph. There's, like I told you, I found the y-intercept because I wanted to know what it was, but it is not actually on the graph. Okay? Going back to what Ty was just talking about, he was talking about trying to use the multiplier to go through and actually fill out the rest of these. Well, our multiplier we said was 3. Okay? And therefore, 2/9 if you multiply by 3, you get 2/3. What happens if I multiply 2/3 by 3? Don't make this too hard. What's 2/3 times 3?
Oh, my bad. 2/3. Okay. 2.
It's 2. Yeah. 2/3 times 3, 2/3 of 3 is 2.
And then 3 times
Okay.
6.
Now, and here's why I say that. So notice, I'm missing a point. It's that point that we already started with. Okay? And so, if I went from -3 to -2, yes, I would have, there it would be right there. Okay? There's the point that we started with right there. Then if you took that, times 3, you get 6. Times 3, you get 18. So you can use that multiplier just to kind of work our way through if you want to. All right, let's plot some points here, at least approximately. So we've got -4, 2/9. So let's say it's about right there. -3, we're about right there. We've already got -2. At -1, we're at 6. And then for 0, we're way up off the graph now, way up at positive 18. And so again, if we sketch this in, way up here. All right, let's take a look then. We said this would be exponential growth because we had a multiplier of 3. Notice the graph matches what we were talking about. And so now, if we just kind of finish off the stuff down below, where's my horizontal asymptote?
0.
It's at y equals 0 for 2 reasons. One, if you take a look at the graph, you can kind of see it sitting right here. Y equals 0. The other reason, we didn't shift that asymptote. Normally, that's where it is, and any vertical shift would take it from the x-axis and move it either up or down. Well, we didn't have any shifts, so it's still at y equals 0. Okay? Y equals 0. What's my domain of this? All real numbers. Yep, we could plug any. I chose these values to plug in for x. I could have chosen anything. Didn't really matter. And what's the range?
Y greater than 0.
Y is greater than 0. That entire graph is above our asymptote. Okay? So there's a little bit more work to this today, obviously. You can kind of see that because of the shifts and stuff. But what I want you to take a look at, like I said, is really the only thing we're adding in is this horizontal and vertical shift. Okay? That's the only thing we're doing is moving that graph up, down, left, right. All right, let's do one more together. Take a look at example number 2.
Holy.
So if you take a look at example number 2, first off, what's the a value? Be careful. It is 1. There's a 1 sitting in front of that 1/3. Okay? It's the coefficient of the exponential part. So a is 1.
Minus 1/3.
What's b?
1/3.
That is 1/3, which means right away, exponential growth or decay?
Okay.
We know this is going to be a decay. Yep. Okay? What's my horizontal shift?
Minus 1.
Yep. -1. And how about my vertical shift?
1.
1. All right, so this time we're going to take our a value, our y-intercept, and we're going to move it to the left 1 and up 1. Okay? So we would start here, and that gets moved left 1 and up 1. And there's our first point on our graph.
Oh, it's the same one. 1, 2.
And now again, the rest of it is, let's plug in some values to kind of round this out. We know that the general shape, because of the 1/3, it's going to start up high, and it's going to decay, come down low. Okay, it's going to end up decreasing very, very quickly. So let's take some, let's go ahead and let's take like -3 and -2. And then to the right of it, we'll go with 0 and 1. 2 points to the left of your starting point, we'll go 2 points to the right. All right, once again, I'll do the first couple here so that you can see it, and then we'll go from there. So if I plug -3 in, we have y equals 1/3. What power would it be raised to if I plug -3 in?
-2.
Yep, we get to the -2nd power, and then you still have a +1. Now this goes back to what we talked about on that homework problem that we went over. You've got a fraction raised to a negative power, which means take the reciprocal to turn that into a positive power.
So it's 3 plus 1.
So, yep, we've got equal to, this will become 3/1 or just 3. Now it's squared.
9.
Don't forget squared on that one time. So 3 squared is 9.
9 plus 1.
9 plus 1, there's our first answer right there. Okay. And -3, we're up here at +10. Remember we said with exponential decay, we're starting off high, and it's going to decay from there. It's going to go down very quickly.
Triangle of that.
Yep, it's about that time.
Again, I know.
Every day.
It's about that time.
After lunch, I'm telling you.
All right, let's plug in -2. So we've got y equal to 1/3. What power would 1/3 be raised to? Now it would be raised when you plug -2 in. The power ends up being -1. And then you still have a +1, which means you take the reciprocal in order to get rid of the negative exponent. So that becomes 3 to the positive first. And then you still have the +1. What do we get for an answer? We get 4. So at -2, we are up here at 4. There's our second point on our graph. Notice we're decreasing very, very quickly, just like we said we would. And then hopefully from here it gets a little bit easier. I'm going to do the rest of these in our head here. We're going to evaluate. If I plug 0 in, 0 plus 1 is 1. 1/3 to the first power is 1/3. Plus 1 is 1 1/3. Or if you want to write it as 4/3, that's fine too. So at 0, we're at 1 1/3. Hang on a second. Where am I going? Oh, they're not right. Made a mistake somewhere. Where did I make a mistake? Oh, I made a mistake on my original point. That's what I did. That original point.
Okay.
I was going from the origin. How come nobody said something? I went from the origin and went left and over. It should be going from 1 left and over. So your original point should have been up here. Because normally our A value being at 1, we would start here and then we'd go over and up 1. I accidentally went from the origin over and up 1. There we go. Now it seems a little bit better. Now we're at 1 1/3. So that decay is continuing. And now last part, we plug in 1. We end up getting an exponent of 2. What is 1/3 squared?
1/9.
1/9. Square the top, square the bottom. Okay, 1/3 times 1/3. And 1/9 plus 1 is 1 1/9. So we're about right there. And now if we go through and we draw this graph in, or if we take a look before I draw the graph in, where's the asymptote going to be?
1.
Yep. And I hope, again, for multiple reasons, as you take a look, I'm hoping that makes some sense to you. 1, because we shifted everything up 1. That's why it's at y equals 1. 2, if you just look at the values, I'm hoping you're seeing that the y values are approaching 1. 1 1/3, 1 1/9. The next one, you'd be 1 1/27. It's going to keep getting closer and closer to 1. So it's approaching this horizontal asymptote right here. At y equals 1. And now we can go through and sketch in the rest of the graph. All right, last 2 parts of this one. What's the domain? All real numbers. What's the range? Y is greater than 1. It's everything that's above that asymptote. Y is greater than 1. How are we doing? Making some sense, hopefully? Get the general idea? It takes some work. I mean, there's a process. You got to work through some of the problems, but in general, once you kind of get it, it's the same idea as you work your way through it. The only thing I want to mention on the last one, if you take a look at the last example for a second, I'm not going to go through the whole process on this one. I'm just going to kind of sketch it, and we'll go from there. First off, what's the value of A on this one? -3. So this is the reason why I want to at least discuss this one. Because A is negative, that means we're going to have a reflection. Okay? It's going to end up reflecting, so we'll talk about that. That's the part I wanted to talk about. What's the B value? Yep, my multiplier is 6, so normally we would have exponential growth, but that exponential growth is then going to get reflected. Okay? What's H? -2, yep. And K is -2. And so just real quickly, if I at least put the starting point on the graph and then we talk about it from there. By the way, as long as we're talking about it here real quickly, where's your asymptote going to be located? Y equals what? -2. We're shifting everything down 2, so that's where the asymptote will be located. Y equals -2. I'm going to put that on the graph right away. Okay, let's put our starting point on here. Normally, okay, we take our A value at -3. So normally that would be starting off right here. But we're going to shift it to the left 2 and then down 2. And there's your starting point right here. Okay? Make sure I don't make a mistake on this one. 1, 2, 1, 2, there we go. Right here. Your A value would be at -3. But then it gets shifted from that point to left and to down. Like I said, without any horizontal or vertical shifts, your A value is your y-intercept. But then you got to move it around based on those shifts. Okay, so now here's the last part. I'm just going to sketch in the rest, just so you get an idea. We said based on the fact that this B value is 6, normally this would be exponential growth. Okay, it would look something like, and you don't have to draw this in, but it would look something like that. Because A is negative, you're going to take that graph and it's actually going to reflect down here below. So it's actually going to end up looking something like this. Okay, that's what the value when you have a negative A value. And again, normally I would plot the points and we'd take a look. But ultimately, just to save a little bit of time, this is what your graph, at least a rough sketch of it, would end up looking like. Which, by the way, how does that change the range? Let's finish this off with domain and range. Domain is always all real numbers, so we've got that. What's my range now? Y is less than -2. That's the one time where we said that the range will actually be less than the asymptote. Okay? All right. So I'm going to get you've got about 10 minutes of class time where you can at least either be working on the assignment from the last assignment that I gave you. Otherwise, I'm going to give you the next assignment. And there's a couple things I want to mention about it once I hand it out. And then, like I said, tomorrow is just going over questions, work time, hopefully giving you an opportunity where I can come around or you can work with some people that are sitting next to you and you can just figure it out and hopefully it's making some sense and you get your assignments turned in before you leave tomorrow. Okay? That's the goal. So let me give you this.
Wait, is that a layer?
All right, one quick heads up about the assignment. And actually, let me just bring it up real quickly. Alright, just real quickly, so if you take a look at this worksheet I just handed out, just a couple of explanations for a second. Number one, you can cross off part C. You do not have to worry about that. There's something with part C that I don't necessarily, it's beyond what I want to be at, where I want to be at this point. The directions for this first problem, when it says to describe the transformations, what they're telling you is this y equals 2x, that's kind of like your starting function. And they're saying, now that I'm subtracting 2, what does that do to the graph? All you're explaining is, like in this case, what does the minus 2 do to the graph? What is it?
It goes down.
Yeah, that's all I'm looking for. It goes down 2. It's a vertical shift down 2. That's all I'm looking for. You don't have to graph it, you're just explaining what happens. In this case, what does the plus 3 do to the graph? No? What if somebody said it? Edwards? Moves, so that's your horizontal shift. It moves to the left. Okay? And then part D has multiple things that are going on there, but that's what they're looking for in this first problem is just what are the different shifts, what's going on, what's happening to the graph. Okay? Alright. Go ahead and go to work, and I will be around and answer some questions here if you need it, and we'll go from there. Okay?